Thanks, Matt. I'll stick to my Indian accent just for today. Welcome. It's always a pleasure to come to London, and it reminds me a lot of a place where I grew up, which is Luton's Delhi. A lot of the buildings here remind me of back home, and one such place where I stay now is the Renaissance Hotel. And the name stuck with me. It's truly Renaissance in terms of what we're all going through right now. In terms of technological evolution, revolution is there, but it's like a more awakened performance from us in terms of how we need to work with data. So that's what really got me thinking in the morning. I'm operating on 2 hours of sleep in the last 2 days, so if I'm a little slow, I'm not as blazingly fast as our platform. Please bear with me. So Matt talked to us about the fourth industrial revolution, and it's a term that's coined because it's about how humanity moves through ages. It's through a process of creative destruction, as they call it. And it goes through this over sustained periods of time. That's when you call it an age. We are in the sort of, so to say, industrial age. It has gone through water and steam-based, then sort of electricity-based, oil-based, and finally the telecommunication. These are the phases through which it has really gone through. And this current one is the one where many systems are going to sort of come together. Biological and cyber-physical systems is where the game is going to be at. And all this requires basically a lot more interaction of data. How we're going to fuse data and how we're going to find insights out of data. That's where the game is going to be played. So we get through these phases because human beings are very good at one thing, which is building tools. I want to talk to you about the tool we are building here, which is our data platform, and how this is going to help with us participating or even staying ahead of this, so to say, the revolution. Now, where do I begin? It's always good to begin at the beginning and give you a sense of what inspired me to come to Couchbase. It's about 5 years ago now. Things are changing, and things were beginning to change 5 years ago, but not to the extent that it should really be. If you had an enterprise application you were interacting with, and you were looking at a consumer-oriented application, you would see a vast difference. If you went to a Google or a Facebook, any of these modern applications, how quickly, how zippy it was, versus if you're looking and working with your HRIS system internally or your expense reporting system, they were all slowish and sluggish and not modern looking. If you really look deep enough, it's not about the UI, it's not about any jazzy stuff that they're doing. What really changes is the way these modern companies are looking at data, how foundationally they are thinking of data differently. That's what really got me thinking in terms of why has that not come to serious applications? Why is it that something that only these large few companies are able to do? That's because the data infrastructure has not been in place, and somebody had to build it. So why Couchbase? This was a place which had, like I say, good bones, the beginnings of a good architecture, and more importantly, the people. People with whom you can have some very demanding conversations in terms of what you ought to be building, some serious conversations in the areas of distributed computing, the areas of databases, in the areas of occasionally connected computing or devices, as we call it. So a lot of good computer science disciplines, like Matt mentioned, serious computer science principles are put to work here in the platform that we really were trying to build. So that started with a very small step of me sort of joining Couchbase and working with this set of people here and improving on the foundations that were laid, which is in the distributed shared nothing architecture that Matt described. Those are the foundations on which we wanted to build. Now, here is a set of people who have really built a lot of application tier stuff about the database tier in the past. That experience comes into play here in a significant manner. Pretty much inside our engineering group, people have built the previous relational version of databases. Every flavor you can think of the Oracles, the Sybases, the Informix, the DB2s. We have all done our tours of duty there. Not just that, since those platforms matured some 20 years ago, we had all moved on to do other stuff like application servers, mobile applications, platforms, integration platforms, whole bunch of stuff. So this comes from an informed place. If we, in our team, the set of people we work with, if we were to think of building the next whatever package software we had all been building the last 10 or 15 odd years, what sort of a database would we use to go do that? What are those limitations in the traditional systems that we would really like to remove? And what is it that we would really like to work with? What would be a joy for us to work with? It has become a little bit of a drudgery to be using some of the older technologies. So those were foundationally the questions that we would ask. And we would want to answer those from multiple contexts. One is of, what are the things that have changed? What do we need to adapt to? And what are those principles that were really good to begin with, which we should preserve? Because sometimes, in the interest of doing something new, you always make something that has been old and tried and tested look like obsolete. That's never the case. You just have to learn from that, adapt, and sort of use that wisely while changing in places where truly the change is required. So what were those foundational stuff that have truly changed? Hardware disruption, we all know this thing. Memory is way cheaper, and networks are blazingly faster. Two, which you could not take into account as a given when the relational systems were built. They were all disk-oriented, and they were single-node architectures. Because back then, in the 70s, when those were built, networks were unknown. I mean, Ethernet was not so popular. If anything, you had LANs, and somebody had to come and lay that. And now you could not have counted on a regular TCP/IP protocol to be blazingly fast on the internet and that you could use to connect devices. You couldn't. Memory, unheard of in terms of the prices that we see now. So even disk space was so expensive that it had to be optimized. Those were the ground realities when the relational systems were built. Now memory is way cheaper, and networks can be counted to be in the middle of computing. That means that you can join two servers together and expect to recruit the resources available on each of these and put that power to use. So basically, it's about chaining pizza boxes as opposed to building bigger and bigger hardwares. At the end of the day, cost. That's what it comes down to. Application development has completely changed. There was no object-oriented programming back then, so no World Wide Web. So the assumptions you basically made about how the applications and how a database had to interact with an application did not have any correlation. So however your memory structures were in the application and however the database held the data, they did not have any correlation. Now you can. And it actually creates a different kinds of a problem, which we call object relational impedance mismatch. Because you're programming in objects, except when it comes to storing, and you're tearing these objects apart, and that's not the smartest way to sort of build efficient systems. And finally, the volume, variety, and velocity of data itself has completely changed. The relational systems were built when you really wanted to bring the ledgers that you had into electronic form. So they look like those ledgers, rectangles, rows and columns. That's what they were trying to accomplish. In the modern application, it's a lot more about the human interaction, which is about unstructured and semi-structured data, and the need for this data to evolve. We call this schema evolution, and that keeps happening on the fly. You couldn't take a system down to make these application changes. So what would be the platform that you want to build to support the modern day needs? And our humble submission is this platform, which we call the Couchbase Data Platform. It's built on a few foundational principles. First, we call this layer consolidation, which is bringing multiple disciplines or systems into one. The best way to describe it is like an iPhone. Before an iPhone came, if you were to describe an iPhone, you would say, well, you can do your scheduling, calendaring, emails, and stuff like that. You can even look up directions in it. And oh, by the way, you can also make a phone call, right? It's about bringing those It's actually 40 devices into one. So that's the consolidation that has really happened in a smartphone. So similarly, this is the one where you have a cache, a database, a search system, analytics sort of fused into one. Why? Because you can bring a lot more logic to the data instead of shipping the data to various applications, right? And that's the main advantage of this one. So layer consolidation. Then we have something called workload isolation. This is what allows you to run different types of queries, if you will, under the same system. It's always about resource contention. Why did you have two separate systems for OLTP and an analytical system? Is because the queries would take different types of resources, and they would contend. And with this workload isolation, our sort of marketing term for this is multidimensional scaling. It allows you to scale the application horizontally or vertically. So that's another principle. We want it to be location unaware data, is what I call it. That's what brings us the mobility into this picture. You don't need to know where the data is actually sitting. It could be on the server or it could be on the device. We'll take care of moving the data to where it needs to be. You simply transact with your application. We will take care of the rest. Then deployment unawareness is another concept here, which is basically whether you are in physical hardware or virtual hardware, on-prem or on cloud, everything should be possible in this platform. So you should be able to sort of burst out or pull something back from a cloud into your physical data center. All those capabilities should be automatically orchestrated, so there should be less manual intervention doing this stuff. Because most of the time in the database world, instead of solving the true business problems, administrators and others get mired into these logistical and sort of managing just the heavy lifting of the database itself. If we relieve them of those responsibilities, businesses will get a lot more value out of the database experts who really understand the patterns of data, how it is consumed, and sort of provision and make the application sort of hum faster as opposed to the mundane activities of managing the database. And finally, this is all about being able to run the stuff at performance at scale. And so the memory and network-oriented architecture and the distributed computing we talked about earlier comes into play here. But the most important element of all of this is ability to interact with this platform should be something that is very powerful and flexible. And that's the programming interface, where we basically brought in the flexibility of JSON and the power of SQL. So very deliberately put SQL back into a NoSQL database. And that's because SQL is the only programming language that has basically survived the last 40-odd years. So many QLs have come and gone, but SQL is the only one that has really withstood the test of time. That's very simple explanation for that. We can talk about that a little bit more in detail. So at the end of it, what have we achieved by bringing all these together, if you really look at it? It's to be able to develop with agility. That's where the SQL capability, along with the schema flexibility, which allows you to evolve the schema, yet not worry about all the mechanics of the relational systems. And once you have developed this, deploy it at any scale, anywhere, which means either on the cloud or on the edge. That's the capability that we have really built into the system. Every other system that is out there right now tries to sort of fake this one way or the other. This one is architected ground up for these capabilities. Now, when you look at it, what is it that, if you think from the standpoint of the cloud, when I say this is basically built for this, and the edge, what is it that really distinguishes the cloud is the elastic capability, or as you call, pay-as-you-go pricing, which is about being able to elastically scale the system. And that requires you to build it very differently. The single node architectures or some of the other design principles others are using doesn't allow this to be naturally scaling. You need that shared nothing distributedness. You need no single point of failure. You need late binding capabilities. These have to come into the platform, which would allow you to really scale as you go. And so this is built for the cloud, And we are doing more work on orchestrators and stuff to make it easy to manage on the cloud. But cloud is old news. If many of you know, some of us started doing this cloud thing back then when it was called ASP, Application Service Providers, they were called. It was in the early 2000s. So cloud is kind of old news. What's new is going to be the edge. The computing power at the edge is way more than what is available in the cloud, so to say. So you really have to think how to basically position yourself for the revolution that's going to happen at the edge. Imagine a traffic light, which is basically now an edge because it's capturing images, and it's going to store petabytes of data daily, the traffic pattern. It needs to only send in the violations. It doesn't have to send in all the images all the time. So that requires you to architect the whole system differently instead of it basically just streaming everything up to the cloud. You want to only stream the information, not the whole noise. So that requires a different type of architecture and different way of building, and Couchbase Data Platform is basically built for that. As we build this platform out, we engage in some serious debate. We have to make some tough decisions. And when we go into these debates, there are, of course, multiple sides. And what we always talk about is, what is the current context? What is the demand in the present conditions, as opposed to get stuck with dogmatic principles that we have always had in the relational world or in the database worlds. So let me touch on a few of these sort of dogmas and sort of give you a sense of how we think about this and how we actually try to move the needle forward instead of getting stuck. So the first of these dogmas is you don't need SQL. This is one of the modern ones. That's how the NoSQL guys came into existence. Oh, SQL is old, you don't need it. But we contend that you need SQL. And why is that? If you really think about this, what basically SQL had accomplished was it was one of the first what we call as functional programming languages, which means it stays at the level of what you want to get done and doesn't get you involved in the how to get it done. If you look, you will see our query language nickel syntax on my right-hand side. Sorry, I always have a right-left problem. On the left-hand side, you see the lovely code still being written. And God forbid, if you miss one of those squiggly braces, your debugging sessions, I've been through many of those. So the beauty is not just here. If you really think, it got me thinking, why is it that SQL has really withstood the test of time? It's very simple. You know, we don't every other day start to think, English is old. It's been around for thousands of years. Let's start a new language. It doesn't happen like that. Humanity doesn't think like that. And SQL is the same way. Because you're able to communicate in SQL, which you cannot do in any other programming language. Two guys who know databases can have this conversation. Oh, how do you figure out this order and this customer thing? Oh, you look at the order table, customer table, do this inner join, and then you can filter this out by this where clause. Yeah, I can see the pattern. This conversation can happen with SQL. Try that with all those squiggly braces. You cannot. So this is why, and because of that, there is an oral tradition, if you will, where information could be passed along. You can share it. Versus a programming language, any other programming language only knows how to talk to a machine. And so that limits how many people you can recruit to do this stuff. Now, a DBA, sort of a community administrator or a programmer, anybody can talk to the data by using one programming interface, which is SQL. So that's the beauty of SQL, and that's why we deliberately put it back into a NoSQL system, because we had to build the whole thing ground up differently. The algebra or the calculus behind it is very different. We called it the generalized algebra for document-oriented data model is what we use to build this thing. JSON actually represents what we call as a nested recursive data model. So the entire query language had to be built differently. And a query language for a non-first normal form data structure, which is JSON, is why that name N1QL that we picked for this one. So you need SQL. Next dogma. Transactions need ACID. We contend you don't. And why? Look at the context again. The context was when ACID was proposed, was when it was all mainframes, one single clock in which the application was running along with the database, and it was all sharing the same context, which is that the application context is where the database is invoked, single threading from the application down to the database, and that's how the results got back. What is the present context, if you really will? The present context is one of microservices, where many of this orchestration is actually happening at the application tier, and each of these microservices has its own needs of scaling and performance. So the real need of the hour is basically scale. Performance at scale is what you basically get. You want lower latency in these scenarios. And then finally, reliability of information. This is what the current need is, not to just regurgitate what ACID really did. You need those principles of atomicity, definitely, and durability. No database can claim to be a database if it's not durable. So you need to have those principles, but we have to evolve on top of it, not just try to sort of refit that into the modern context. It doesn't really fly. So that's what we have really done here. You can do many of the stuff without the complexity that was introduced because of the relational model. I told you about the object relational impedance mismatch. This is where it really shows up. One order with 3 items. Imagine you bought a toothpaste, a toothbrush, and a mouthwash. In a relational system, it would be 4 inserts, or 4 updates at least. An order table and an order item table with the 3. In a JSON, these could be in one document. An order object with an order item object embedded. It's one atomic transaction now. With one update to that document, you can do the order and the order item inserts. Complexity that was introduced because of your ORM mapping and stuff like that is gone now. And you can do many of the stuff simply. There are going to be scenarios where you want those sort of multi-part and other capabilities because of relationships between an order and a customer, imagine. Those are required, and we have to find the right answers for those. And we are working on many of those stuff. There are patterns available now to accomplish that. As we keep progressing, we will start to add many of those capabilities in the platform as well, but not just give you a pat answer to say, well, there is ACID here. If you do that thing, you will lose these capabilities, which is what you need now. Scale will be lost, performance and latency out of question, and of course, you will pay some cost for reliability as well. The last of these dogmas, because people are so protective of the data, is when you go to the edge, I want the application logic on the edge, but the data will still be central because it's protected. It's still sitting in my mainframe or whatever those systems are. That is where the current thinking is. We have to go away from there. The data has to be on the edge. Data has to be close to where the action is, where the actual application is really working. And that's what will give you the always-on capability that you need these days. Because irrespective of failures, your application should be up, which means even if your cell tower goes down, your application should be working. Eventually, the data can be synced to the cloud or back, however you want it. But the application should not be waiting, and that circle of death should not be the one flashing in front of you all the time. Most of it has got nothing to do with bandwidth. It's got to do with the fact that the data is sitting behind umpteen firewalls, and it has to basically sort of cross through all those things with unnecessary processing. Bring the data to the edge. And now, but building this is very difficult. You have to do with conflict detection, resolution, data movement, eventual consistency, whole bunch of really serious problems to address. And so far, and I've built a couple of these in the past, these were all addressed at the application tier. We are trying to bring that into the data tier so the application tier doesn't have to deal with all this stuff. By few configuration and some logic, you should be able to move the data from the cloud to the edge. Now, that's how we basically built our platform, so you can now very quickly start mobile-first applications if you want, and then add your web front, or the other way around. Both are possible. Simple, consistent interface, whether it be on the edge, because we have a local database on the edge, along with the sync capabilities built into it, or from the cloud. Both are possible. Now, you'll ask the question, why Couchbase? Because at a certain 10,000-foot level, it might look like everybody can do this, because it's just, marketing, right? But when it comes to actually being able to do this thing, you will see the beauty. Actually, let me plug for that here. Come for my demo in the afternoon. I'll show you how it's all done in one platform. So, because without introducing any external services and sort of mobile backend as a service and all that stuff, you can do this here. Why no one else can do this is those principles I described earlier, which is the shared nothing memory-centric architecture, the workload isolation, the location unaware, the deployment unaware, all these concepts coming together with a SQL on front for you to program to it. No single platform has all these things built ground up to simplify the problem. Now, very clearly, this is a data platform that we built based on our experience from the past. We brought in all our experiences of having worked with various packaged and enterprise-grade software, hosted applications, mobile applications into one. This is a data platform which addresses the concerns of enterprise developers, which means we understand all the abilities that you want: programmability, extensibility, scalability, performance, security, any of these concerns that an enterprise developer would have, we have deliberately considered those and addressed those. Now, I began by telling you about my journey here at Couchbase. It's been a fantastic one the last 5 odd years. We believe we have truly moved the needle. I have, through this process, not just enjoyed what we have delivered, but learned a lot. Learned a lot because my development team keeps me honest. They tell me what is it that I don't know and what is it I need to brush up. So it's been a great learning experience. And at the same time, what really excites me is the possibilities. Products and services have been built on this which we did not imagine when we got started. The kind of scale and performance which Matt talked about earlier is something we had dreamed of. Only when an Amadeus really takes us to the shop with their scale and performance, or when United puts us to use as an ERP tier. Every flight, they have 27 different projects going on with Couchbase, all the way from wheelchair access to that plane getting scheduled has a touch point with Couchbase. When you see, or a BD when it does insulin tracking, and then that information could be sent to the doctor, irrespective of whether you had network coverage or not, or a SyncThink, which can do a concussion detection by just looking at your eyeball movement and the data being sort of eventually analyzed in the back end, all the way from our mobile front end to seeing patterns. When you see such applications being developed, then you know you're really on the right path in terms of enabling new services and new offerings which weren't imagined when we even got started with this project. So I hope, in some small way, I have inspired you with these examples and what we have thought about in building this platform to take that one small step, which I'm hoping will be the start of your own revolution. Thank you.